Hey everybody, I'm sometimes asked about how we protect ourselves out on the track when we're working. People wonder if we can just go out there and do things and how we keep trains from running over us and stuff. And no, we can't just go out there and start doing things. We need to make sure that we are protected out there. And there are a few different options that we have as far as keeping ourselves safe out there and keeping us from doing things that would cause a signal to go red, that might cause a train to have to come to a stop, or knock down a route the dispatcher is lined, and then it takes, everything has to run time, and it could take up to 10 minutes before they could re-clear signals. And believe me, when you make those kind of mistakes, you're not very popular with anyone, with your boss, with the dispatcher, the corridor manager. Everybody's mad at you. So it's a good idea to make sure that you're conversant with the types of on-track safety that you need in the area where you are working. And so let's go over some of those, and I'll talk a little bit about the different types of locations we have, what types of on-track safety we use at those locations, and how we keep ourselves safe out there. Okay, the first thing we'll go over is what things are. We'll start with the control points. You've heard me talk about those before in other videos, where trains are, whatever. And control point is any location that is controlled by a dispatcher remotely. And by that I mean, right here you have a power switch machine. These are signals. That's the symbol for a signal. This signal is an entering signal or a facing signal, and the top head controls movement up the main line. The bottom head controls movement through the turnout and into the siding, or onto, in this case, we've got the number 1 track and number 2 track if this is going to be double track. And then these two signals here control movement out of the main line this way. This one controls movement through the turnout out onto the main line. And this could be, like I said, the end of a siding or a double track. Then right here you have a crossover, and you have number 1 track and a number 2 track, and a crossover between main. There are locations, such as the Bealville crossover, where they have a crossover actually in the middle of a siding because it's a long siding. That's not all that common, but they do have them. But anyway, you'd have a crossover going, in this case, from the number 1 track to the number 2 track, or the other way if you're coming the other way. And there are also double crossovers where you have this crossover, then another one going the same way. The Tehachapi crossover, the Sandcut crossover, those are both like that. So those are control points. This would be the number 1 and the number 2 track between control points, or if you were in a siding, this would just be the siding and the main line. Out here you have single track, and you have a control point here, and out this way you would have another control point. But for all our purposes here, between control points you would have intermediate signals. Intermediate signals are automatic signals. They work automatically. Their normal position in both directions is clear or green. They don't necessarily have to be green. Say in this situation, the normal position of this signal would be yellow, because the normal position of a signal at a control point is red. So a train coming this way, if the dispatcher had not cleared that signal, then this signal would be yellow, telling him he's going to need to come up and stop at this signal. If he was going to go into the siding, this signal would be red over yellow, or red over green, or red over flashing yellow, red over clear. This signal would be yellow over yellow. Or in the situation of the approach to BINA, say, which is an equilateral switch, it doesn't have this, it looks more like a Y, higher speed turnout, you can actually get a yellow over green because you can take the turnout at a higher speed. This would be a hand throw switch out here between control points, and this symbol right here, you can have an electric lock, that's what that symbol right there is, or you can have a come out signal. Both of those are intended to protect the main line from trains just coming out of a spur track or a branch line, whatever it is, onto the main line. They have to have permission from the dispatcher. They stay behind these joints here, and they would go out here, unlock this lock. If everything was clear out both ways, the lock would just unlock. They could come out onto the main line. If any of these tracks are occupied on either side, this electric lock would have to, the circuitry would cause it to run a certain amount of time before that unlocked, which would give any train that might be out here time to get by that switch. They're not designed to keep trains from going into the track. They're designed to keep trains from coming out without permission. Down here you have an interlocking. This particular drawing right here that I did, this is what the Mojave interlocking looks like. Bakersfield's this way, Palmdale's this way, Barstow is this way. And this would be the Mojave yard, the yard tracks, and it has a signal coming out onto the number 2 track. This is a tail track. It also has signals coming out onto the 2 track, and these signals here control movement this way. This signal controls movement from, this is the Union Pacific line going up Palmdale. And you have this signal coming into the yard. I didn't draw the signal here, but this is the BNSF, and it splits off at Mojave and goes out to Barstow. And it also has a signal that comes into the yard. And these signals, these switches can be lined however the dispatcher needs to make a move. They need to bring a local out of the yard and out to Palmdale. They'll line these switches appropriately. This signal here will tell the train what they need to do, as will if this signal here, if the BNSF is coming in this way, and they'll have to go through a crossover and, between the number 1 and number 2 track and out onto the BNSF. But that's an interlocking, and that is an interlocking is where 2 railroads cross each other. Or split off. Conjunction is the same essentially as this, where the BNSF splits off and goes into their yard in Bakersfield, and UP splits off and goes to theirs. You can also have interlockings that are simply like this, where you have, one railroad going this way, one railroad going this way. They used to have one in Tulare where the Santa Fe and the Southern Pacific crossed each other. They have them, there's one up in Stockton, Calwa in Fresno, where the BNSF crosses the Union Pacific at the south end of Fresno, and that one's essentially a cross, but it's more like this. But anyway, so those are the different types of locations that we'll be dealing with when we talk about how we protect ourselves. Okay, we will start out with what is called individual train detection, ITD. ITD is for use anywhere but a control point. You cannot use ITD in a control point. You have to have positive track protection to work in a control point. But ITD can be used out here. You can do minor inspections, minor repair work, anything that doesn't require the use of power tools that may keep you from hearing a train approaching, and or anything that would take your attention away from the tracks for more than a few seconds, where you would not be able to see a train. You could see it, but you wouldn't notice it. You wouldn't want to be distracted by working on a switch or making a little minor repair or something. And ITD, you can't do anything that will affect the signal system. It's just simply for minor repairs, and you have to fill out a paper that tells you the track speed. You have to know the track speed, sight distance for that track speed, and you have to be sure that you can see that far. ITD can't be used at night, can't be used in the mountain curvy territory where you can't see more than a few hundred feet. With the ITD, you don't have to have permission from anyone to go out and do anything here, as long as you're outside a control point. And I did fail to mention that the interlocking is the same thing as a control point. You cannot work in an interlocking without permission and proper on-track authority. You also, with individual train detection, need to be able to clear the tracks 15 seconds before a train arrives. So you need to make sure that you're watching what's going on. And that is why you can't get involved in any kind of a job that would keep you from being able to clear the tracks 15 seconds in advance of a train. Okay, track and time. Track and time is, you call the dispatcher, or in the case that we use now, remote track authority. We have a program on our computer. We use that program, type in the information we want, and that is sent to the dispatcher. The dispatcher looks it over, and if it's okay, they will grant you that authority. You can still get track and time on your cell phone by calling the dispatcher or on the radio, but they prefer us to use remote track authority. And track and time is given out between control points. Say you wanted to do some work on the number 1 track right here, you would request authority between, say, this control point number 1 and this is control point number 2. You would request the number 1 track between control point number 1 and control point number 2 until such and such time. And once you were granted that authority, you could go out and do whatever you wanted here. They can't run trains in there as long as you have as long as you have tracking time. They'll block these signals so no trains can enter there. Foul time. Foul time is granted at control points. If you want to test a switch or go out here and fix something or put some bonds on the rail or whatever, you would get your remote authority or get in touch with the dispatcher, and you would request foul time at control point number 1. And when they granted you that foul time, then you could go out here, you could take the power off the switch and throw it by hand. You could do whatever you needed to do out there with foul time, and foul time is only granted at control points. A track permit. Track permit is given in an area of track where there is no centralized traffic control. Centralized traffic control is that would involve the control points, and we have sections where we have a control point here that's part of centralized traffic control, and say this control point here was centralized traffic control, but the track between them isn't necessarily CTC, centralized traffic control. It can be automatic block, and we have a situation like that up in Fresno between Calwa and Biola. You use track permits, that is automatic block. But out between Kern Junction and the Sandcut crossover is automatic block. In those areas you would use track permits, and they work exactly the same way as track and time. Just track and time is used in CTC territory. Track permits are used in non-CTC territory. Okay, Form B. Form Bs are used when there is say a track project going on. Say they're changing ties between this control point and whatever control point's out here, or between these 2 control points, whatever. Just imagine that this area here is 10 miles long. They would request in 12 hours in advance a Form B from the dispatcher, and they would be granted that. Now with a Form B, they come out here, the Form Bs start at a specific time in the morning. They have flags that they would set out, say their work was going to be right here. They would set a flag a mile from here and another one a mile from here, and this first one, as the train approaches it, when they see that flag, they have to call the foreman in charge of the Form B and get permission to move through his work limits. If they can't clear the track, if they've still got equipment out there, then the train has to wait. But this is designed to keep trains moving if possible. And Form Bs are requested for all-day jobs. Say they're going to be out there for 10 or 12 hours. The train would come up, call the foreman in charge, give him all the information of the train. The foreman in charge would talk to the train and tell him he has permission to pass through his Form B limits. He would give him a track speed if that was necessary. And once all that was done and they had communicated with each other, the train can move through the Form B. Track warrants. Say you're going to go out here and this is the Lone Pine branch. The Lone Pine branch is a non-controlled branch line. It doesn't have signals. It's not CTC. The dispatcher has nothing to do with it. So if a train wants to come out here and work, or if say a track gang wants to go out there and change a rail, they have stations, and say this is the Lone Pine branch, you'd have Chaffee just outside of Mojave right there, and here you would have gosh, I don't even know what the next station is out there. I don't think there are any stations out there anymore. But anyway, you would request a track warrant from station A to station B, and that would give you permission to work from the first switch at station A to the last switch at station B. And so that's how a track warrant works. Lookout, hey, my little L got messed up there. Lookout is if you have two people, you can use lookout anywhere. You can use it in a control point, you can use it out on the main line, you can use it in non-control track, you can use it in interlocking. You have some co-worker, we actually have yellow vests that say lookout on them. They put that on, you fill out a little book that's a lookout book, and with all the pertinent information, and then you go out and you do what you need to do. You can't affect the signal system under lookout. It's just for doing basic repairs. As long as you're not going to open a switch or anything, you can use lookout. It's just for fouling the tracks. The lookout stands right next to the person who's working, and welders use this a lot. The welder's down there welding, or the signalman's down there messing with the adjustment of a rod or something. And the lookout can perform no other duties other than being a lookout. He can't help you. If you come to a situation where it's going to take two people to do the job, you have to acquire some sort of on-track safety through the dispatchers, positive track protection. And but anyway, the lookout, that's his job. It's all his job is to look out. He watches for trains. He sees a train coming. He tells the guy he's looking out for, they pick their stuff up and get out of the way and let the train run by, go back behind him and do it again. Now we also have TAWs, Train Approach Warning System. We don't use those around here. I've never even seen one except in training classes. And those are usually at crossings, sometimes at control points, I guess. I said I'm not really that conversant with them, but that's a system that is operated by a key or a push button that's in a box, a locked box on the side of a control cabin, whether it's a crossing or control point. And whoever's going to use that would go open that box and activate the train approach warning system. And say it was at a crossing, when the train got on the approach of the crossing, when he crossed the shunt to get the crossing to start working, the TAWs system would see that and it would go off. There's a siren, a blue flashing light, and whenever they hear that, everybody gets in the clear, deactivate the TAWs, wait till the train goes by, reactivate the TAWs. It's my understanding they're no longer installing those, and they're trying to get rid of them at the places they do have them. I know I would not be comfortable using that system. So anyway, that is a short description of the types of places where we work out here and the types of protection we use to keep ourselves safe out there. Well, for those of you who had questions, I hope that answered them. For those of you who didn't have questions, I hope that shed some light on it anyway. It's how we protect ourselves out here, protect ourselves against train moves, equipment that's on the track that doesn't need to be coming where we are, and to keep us from affecting train movements. We don't need to be throwing red signals in front of trains or lining switches against them, whatever. And this on-track safety is designed to minimize those incidents. Also, with the advent of positive train control, that's helped minimize them even more. But positive train control only works on locomotives. If a car gets away from a work train or for some other reason gets to rolling down the tracks, and that does happen, you're not going to have any warning. Your on-track safety is not going to help you. So it's always a good idea to keep your head on a swivel, as they say. Look up every 30 seconds or so and see if there's something coming. So anyway, things can still go wrong. People can get on-track safety in the wrong place. A dispatcher could clear a signal into an area where he has tracking time, he or she has tracking time. It's not that common for that to happen, but it does. And so there again, it's always a good idea to keep looking around, make sure everything around you is okay and there's nothing coming. But anyway, that is how our on-track safety works, what we do to protect ourselves, and then a little primer on what kind of locations we have out here and what we work with. If you have any questions, put them in the comments below. If you have any ideas, as usual, put those in the comments, shoot me an email, and we'll see what we can do about it. We'll see y'all later.